Greetings and welcome, ladies and gentlemen. We're talking about ellipses, our day 2 writing equation of ellipses. We're looking at problem 27 on page 638. Here's the equation of ellipse in general form. I just want to point out I know that this is an ellipse because I've got both an x squared and a y squared term. They have the same sign and they have different numbers, different coefficients. So first thing I'm going to do is group the x's and y's. So 12x squared minus 48x plus 18y squared minus 144y equals negative 120. And because of these leading coefficients, I'm not GCFing here. I just am taking out the 12 here, whatever those coefficients are, and 18. So I'll have 12 times x squared minus 4x blank, close parentheses, plus 18 times y squared minus an 18 into 144, 8. All right, I'm glad you're here. Wait, yeah, because both of the 9s are taken. Okay, yep. 8y blank equals negative 120 blank blank, and this literally takes up the whole width of my page here for us. So now I'll double complete the square. So negative 4 divided by 2 all squared equals negative 2 all squared equals positive 4. So plus 4 here. But adding 4 in the world of parentheses was really adding 48. So I have to add 48 over here. That's the common place for mistake. And I will have multiple choice questions that have that exact thing. Like if I add 4 here, what do I add over there? Stuff like that. For the y's, I'll have negative 8 over 2 all squared. Negative 4 squared is 16. So I'll add 16 in the world of parentheses. And 16 times 18 is 288. So let's factor the left-hand sides. So I'll have 12 times x minus 2 all squared. That's a weirdly spaced parenthesis now. X minus 2 all squared. There we go. Plus 18 times y with what squared? Well, that's the negative 4. Y minus 4 all squared equals, and let's see, 288 plus 48 minus 120 is 216. So, elliptical equations are always set equal to 1 in standard form, so I'll divide everybody by 216. And let's see if I can do this properly. This is going to be tricky. Now, are you guys telling me that 12 doesn't go into 216?
I might have messed up.
Oh, okay. Because that can happen, and those problems become really tricky, or trickier anyway, where you'd end up having like a decimal or another fraction in your denominator.
I have like 212 as my denominator.
Let's see, 216 divided by 18 must therefore be 12. Equals 1. So here's standard form, standard. Let's gather the information I know. I know that the center is at 2, 4. I know that a is equal to the square root of 18, which is the square root of 9 times the square root of 2, which is 3 square roots of 2. If you simplify that, I know that b is equal to the square root of, lag out. Square root of 12, which is equal to the square root of 4 times the square root of 3. So that's equal to 2 square roots of 3. Right? Which way is this parabola, or sorry, ellipse. I'm there. I'm getting there. Which way is this ellipse oriented? Horizontal, because the larger denominator is paired up with the x. By the way, sometimes the book, I don't know if you realize that, they'll actually put like the larger fraction always out front, or the larger denominator fraction always out front. So just be careful of that in case somehow like you got thrown off because they threw a y there and then the x. I'm always a fan of doing x then y myself, but hey. So yeah, this is horizontal. So let's find out what c is equal to. We would do that, of course, using the a squared minus b squared equals c squared, which unfortunately is another formula you have to memorize. So I'll get a squared is 18, b squared was 12, equals c squared, so 6 equals c squared. C is equal to the square root of 6, right? So there's c. So let's find our vertices. Are going to be, well, let's see, it's horizontally oriented. So I would have 2 plus or minus 3 square roots of 2, comma 4 for my kind of primary major axis endpoints vertices things, right? And then I'd have 2 comma 4 plus or minus 2 square roots of 3 as the endpoints of the as the endpoints of the minor axis. Wow, I'm just mixing up all my words today. The foci, which by the way, I could find decimal approximations of all 4 of those points, but this is fine. If they're radicals and exact, just leave them like that. You don't even have to separate into the 2 plus and then the 2 minus. Leave it just right like that. For the foci, I'm going to add and subtract c on the same axis as my major axis. So I will do 2 plus or minus the square root of 6, comma 4 would be where my foci exist. Did they want a graph? No, they didn't. Oh, they did. Oh, blast. Oh, bother. Yeah, I'm going to... oh, bother. Here we go. I'm going to make some room for myself real quick. So how you doing, internet friends? You guys all having fun? Yeah? What's your favorite SpongeBob episode? Mine's probably Doodle Bob. It's pretty good. Guys, you get a magic pencil. I don't know. It's pretty great. Patrick gets hit by a bowling ball at one point that was drawn by the doodle. And then when Patrick gets hit, he shouts the word Finland, which I'm a big fan of. So basically my two worlds collide right there. So anyways, now that I've finished rambling and drawing, my center's at 2, 4, square root of 18, square root of 12. So those are all like, let's see, square root of 12 is going to be 3.3-ish or something. Square root of 18 is probably going to be like 4.3-ish. So I need to go out a little ways. And it looks like I'm mostly going to be in this quadrant, right? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And 1, 2, 3, 4. That's good enough. 1, 2, 3, 4, 5. And hopefully this fits everything I need. So I've got a center at 2, 4. So over 2, up 4, right there. My vertices, square root of 18, like I said, is probably about 4.3 or 4.2. So I'm going to go from 2 over 4. 1, 2, 3, 4. That lands me at 6 and a little bit extra. Subtract 4, so there's 2, and then subtract another 2, and then a little bit of change. Right there-ish is probably where that vertice would be. Vertex, I guess, singular version. Yep. Then I would go up and down by, that's probably like 3.3-ish. So 1, 2, 3, and a little change. And 1, 2, 3, and a little bit of change right there.
How are you finding these points?
I estimated the value of the square root. I mean, I could actually have found out the exact value of the square root if I wanted.
The square root of what?
When I did the square root of 12 was the value of b.
Okay.
So that's why I went up. Whoa! Silly me. I gotta reselect my little scribble tool here. There we go. So yeah, I went up the square root of 12 units, or 2 square roots of 3 units, and that I estimated was at 3.3-ish. Which, I mean, for a graph, that's close enough. I'm not going to notice the difference between 3.2 and 3.3. Right, and I went down that same amount, and then for my a value, I had square root of 18, so I estimated that to be about 4.3 as well, or maybe it's 4.2, something like that. Right, so I went over 4 units and a little extra. And now for the foci, I'm going to add and subtract the square root of 6 from the center along the major axis. So square root of 6 is probably like 2.4 maybe, something like that. So I'll go over 1, 2, and a little change, and then go backwards 2 and a little change, and there's the foci. So that is the square root of 6 distance, which is probably like 2.4 there. So there would be my graph, something like that, and we are good. Let's see if I can do one more problem. Hopefully I have enough room for it. I think I will. It says the endpoints of the major axis are at negative 11, 5, and 7, 5. Okay. And the minor axis are at negative 2, 9, and 2, 1. You know what? This time I'm gonna kind of draw just a better graph. I just want to point out that if you draw a sketch or visualize a sketch, or even just look at the coordinates of that point, you might be able to figure out what the orientation of this is. So let's see. Let me plot some points. Now, before I actually do, the major axis. Okay, so this is A is going to be related to these values. Now, notice these two values. All right, these two coordinates. Notice the y coordinates remain the same, but the x coordinates are different. If these are the endpoints of the major axis and the x coordinates are the ones that are changing, that must mean that this is a horizontally oriented ellipse. Okay, so see how I was able to just kind of gather that information from that? That's the sort of stuff you want to be able to do. So 7, 5, those are those endpoints, and the endpoints of the minor axis. And in this case, notice that the x coordinates are the same, the y coordinates are different, so that would make sense. Oh, negative 2 and 9, and negative 2 and 1. There we go. So there's a rough location of my ellipse. By the way, if you were to rotate your ellipse over your major axis in 3 dimensions, the name of that figure resulting would be an ellipsoid, which is the shape of a football. So, little known fact. Well, maybe not, but now you know, though. So let's see. So my ellipse is probably looking something like this, right? Something like, and so I just want to point out the information that I already know. I know that this is horizontally oriented. Let's see, let me grab a better yellow. Horizontal. Right? I actually can figure out the center just by looking at these points as well. Negative 2, 5. All right? Because think about this. The midpoint, or the center occurs at the midpoint between either of those pairs, right? And the average of these y coordinates must have been the 5, and the average of these x coordinates must have been negative 2. So that's the only way that that could happen. So without even having to do any math, I was just able to kind of know that by kind of looking at that. So negative 2 up 5 lands me right there. Not bad. Not bad at all. And now I can figure out what is the length of A and B. So A is either this distance, right, the distance from my center to either this point or this point, or A could be half of the entire distance, right? Right, half of that distance would be the value of A. So let's find that distance. So A is equal to, well, the distance between this and this, I would just do the absolute value of 7 minus negative 2. Because since they're already on the same y value there, I just really have to compare the x values. So I'll get A equals 9. Did I do that right? 1, 2, 3, 1, 2, 3, 1, 2. Oh, wow, that is 9. Feels longer than I thought it would be there. B is going to be the distance this way. Now I've got a nice graph, so I can just count it. But also, let's just compare it. So compare this to this. Find the distance. That's going to be 9 minus 5, which is 4. So there's the value of b. So now I can find the value of c. So c squared is going to equal 81 minus 16, right? A squared minus b squared. So c squared is equal to, what's that, 71 minus 6, 65. So c is equal to the square root of 65, which I am guessing is super close to the square root of 64, which is 8. So this is probably like 8.1, maybe even 8.0 something, right? So something like that, right? Because it's so close to the square root of 64. So there are my foci. So if I wanted to even graph that, I could go over 8.1. So there's 8. And wow, this is actually a very eccentric ellipse because the value of A is going to be so close to the value of C. And when that happens, the ratio of C over A is going to be very close to 1, right, when those distances are very close to each other. And then I have a very elongated and eccentric ellipse. Let's see, what else do I have to do? I just have to find the equation, I imagine? Yeah. And since I know that it's horizontal, I know that my equation is the x minus h all squared plus y minus k all squared thing equals 1. And my denominators will be, well, a squared is going to be under the x because of the horizontality of it. Horizontality. I want to use that word every day in my life. So let's see, x plus 2 all squared over a squared would be 81, plus y minus 5 all squared over b squared is 4 squared, which is 16, equals 1. So there we go. La 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 la. There is a standard form for our equation. I even got a little bit of a graph here for you. So either through visualizing the location of these points or actually drawing it out, you can gather some information very easily, which I think is nice. So I think that's all we need to do today. Thanks for watching, Internet friends. Have a great day. Bye-bye.